Hello everyone. Good morning. Actually, only three people are there. Why this is? Hello, sir. Hello. Am I audible to you? So, have you done any work on the cross validation technique? Because in the last session we have done a lot of work, right? Even you have worked on the random forest and all. So that might be important, but I don't know that you guys have done the work or not. So can I share one assignment to you so that I can connect with you continuously? Is it possible from you? Because in the last session, means in the Saturday also, Saturday's work actually I have covered in the Sunday as well. So I would like to share some important topics to you so that you can check once, right? Is it possible from you? Hello. Is it possible to work on the Yes, I think in the I have implemented the random forest to measure. This is extra that I have done the work on it, right? So once I would like to go for that. You can check this, right? The voting classifier that I used. But is it possible from you to use the random forest into the cross validation technique? Because already you have used cross validation techniques. Yes or no? So that I'm just giving you one assignment side by side so that I can stay online with you and check the work, right? Wait, I'll check one data set from my side. Can you please review random forest? Yes, as well. Yeah. See, the first point is that what is a random forest, right? The major thing. Random forest is one of the type in the ensemble technique. The most of the things that random forest is nothing but you have to take a random samples. What I'm saying? You have to take random samples from major data set. So suppose there we have the diabetes data set, and in the diabetes data set there we have some amount of data, and in that even we have checked our regular process about balancing or not, and that we have done with the random or sampler, not an issue. But at the end, when we got a proper data set, and there we have used a X train and X test, like Y train and Y test, that's correct. So these are the data sets already covered that we have taken. But what is the work of random forest? Wait, I will come up to the random forest. Random forest by default works on the decision tree. What I'm saying, by default, he can internally take the decision tree. So random forest classifier is one of the algorithm, not an issue. But random forest contains the decision tree as well. So whenever I pass the n estimator is equals to 10, see what I'm saying. Whenever I want to use a n estimator is equals to 10, so that much count there we have classifiers of decision tree. So I will show you one diagram. Side by side, we can go for the diagram as well, right? Because I will take a design first. See, is it visible? No. So what is the major work related with this? Means random forest. Not only I'm just thinking about random forest, I would like to go for the ensemble technique as well. So actually ensemble is nothing but it's like this. See, this is ensemble means you are gathering, you are ensembling, right? But the major task about this one, if suppose you have created a training set is nothing but what? You have created the testing and training set, no? X test and Y test, X train and Y test. So these are the four parameters already ready to train our model. But the point is that whatever the X train and Y train that you have created, you are going to make a samples from that only. You are not creating duplication of data. Means you are not creating like a what? It's kind of not a cross validation technique. In the cross validation technique, there we got an unique values in each loop, but here we are not implementing on the basis of loops. Here we are creating a samples n estimators. So these are the estimators. These are estimators. So in the previously that you have seen one thing here, that is n estimator is equals to what you have added. N estimator is nothing but 10 you have added. So how many samples that you have created? 10. Are you getting my point? So 10 samples you have created, but each sample, how much samples? See what I'm saying? How much samples you are taking, that much classifiers that he is going to contain. If suppose what is the meaning of classifier? In the other words, you can say base estimator as well. See, you should write down that content. This is nothing but base estimator as well. In the other techniques of ensemble, there we have one chance to add different types of algorithms. But in the random samples, means random forest, you can use base estimator as a 4 as well, 5 as well, 3 as well, 2 as well, it doesn't matter. But all the content goes into this classifiers. All the content goes into the three. If suppose you are taking 10 and you are not passing a base estimator count, then the count of n estimator is equals to the count of base estimator as well. If suppose you are passing base estimator is equals to 5, then 10 is remains same and base estimators are 5. But now you guys are thinking about what about if suppose what about base estimator? Base estimators are nothing but classifiers, and that classifier is nothing but decision tree. So decision tree is an what? Decision tree also a classifier. What I'm saying? Decision tree also a classifier. And this decision tree, if suppose you have created n estimator is equals to 10, then that 10 n samples means n estimators are using decision tree each time. Each samples has each different classifier. So that is the only factor that random forest using a decision tree internally. So whenever you go for prediction, just one thing that you will get a different, that is he will create a samples, pass into the classifier, he will give the output. Everyone has a different. Suppose 0 and 1 is concept, then he is giving 0. Suppose he is giving 0, 1, 1, 1, and then meta classifier is nothing but your voting classifier. Are you getting a point, everyone? And that voting classifier says 0 and 1. Now the point to be discussed. So in which concept you can change the classifier. See, there we have the bagging concept. That so that I'm going to tell you about this one as well. Okay. Now, wait, I will show you one thing here. I have created one slide as well, so it will be useful to you, right? Sorry for interrupting. Now you got the point. Can I explain one again? See, ensemble technique has on three types. Not on three types, but three techniques: that max voting, averaging, and bagging. Max voting, you know that max voting works on the majority of work that original data is dividing into the three sectors. Four means it depends on how much n estimators are there. See what I'm saying? Max voting is nothing but how much n estimators are there. That much model you can define. The subsets multiple, the models multiple, and that original data is going through the subsets and subset going through the models, and model give you some kind of output. What I mean, some kind of output. If suppose probabilistic output is there and 0 and 1 you will get. So every model gives you some kind of 0 and 1. Subset 1 gives you something, subset 2 gives you something, subset 3 gives you something. But on the basis of your output, you are getting the combined prediction. That is nothing but max voting. And max voting has an classifier. Max voting has an his own functionality. So how it is? The definition of max voting, you know that generally used to classify problems. So technique that multiple models use to make a prediction for the each data point, and whatever the each data point gives you output, that majority voting will comes under the max voting. So here we have the training test data set and created the models, and models use your output and more. The diagram shows you the voting point. And then we got the final prediction. The same funda, same concept that we are going to implement into the voting classifier using the voting classifier. sklearn.ensemble. Ensemble is my library importing voting classifier. If suppose if I'm using the voting classifier, I have to create one object, a max underscore voting, and voting classifier defines. In that, you can see one thing that in estimator. In the previously that I have shown you one code, in that you have seen one concept that is an n estimator. So I would like to show you one thing that an n estimator is equals to 10 that previously we have seen equals to base estimator. But here what happens? Estimator is equals to random forest. Random forest is my name of algorithm. Random forest is my name of algorithm, and random forest object is an RM. So you guys know that RM is equals to random forest. Already you have defined. Is it correct? No. This is my object. Are you getting my point? RM is my object of random forest. Logistic regression is an object of logistic regression. KNN is an object of KNN. So that similar kind of that I'm passing here RM, LN, L1, and KM. The way I'm passing, the whatever the data will goes through the max vote. See, max vote and max underscore vote is equals to means dot fit. I have trained X train and Y train data to the max vote. If suppose a single max vote is learning X train and Y train, that means the three algorithms are learning same time. Everyone is learning X train, Y train, X train, Y train, X train, Y train. Everyone is giving you the some kind of answer through Y predict is equals to max vote dot predict X test. So similar kind of X test you are asking to the individual RM, no, means random forest. In previously, if you have used logistic regression as well, then you are asking to the max vote dot predict and X test giving you X test taking all the inputs, max vote variable taking all the inputs from the X test, asking to the everyone, and everyone is giving you max Y underscore pred underscore max, and that output will show you. AB is equals to max vote dot score. Score is nothing but accuracy score. That's it. This is your max voting. This is a very interesting point that you can trust on your model, because you are asking to your model that you are asking to your data set, please go through the 3 randomized classifiers. Instead of working on the individual sector, you can work on the voting classifier, and that's it, you will get an output. There we have the concept like a hard voting and soft voting. The question I got that from 3 models we are getting result. Yes, from the 3 models, but voting classifiers not showing you 3 different answers. Voting classifier shows you combined answer, max voting. Yes, sir. Are you getting? Now the point is that everyone has a different output, but because of max voting, the combined into the variable, and then max vote dot score x test y test. That's it. You will get an output that means easiest part with the max voting. Now there we have the types of hard voting and soft voting. Hard voting is picking up the prediction with the highest number of voting. Picking up the highest number of voting, and soft voting is nothing but combining the probabilities of each prediction in each model and picking the prediction with the highest total probability. Highest number and highest total, these are the two different types. Highest number of votes are nothing but 3 is to 2. That is an highest. And highest total means count and making the total is two different points. No, count is nothing but how much ones are coming. 3, 1, 2, 3. How much highest counts are coming. If suppose in the probability you will not get a difference here, means you can use the hard voting or soft voting. In the probability you will get a same answer. If suppose you are going through the multi classification, then definitely you will get a difference between the hard voting and soft voting. Is it correct? No. In the multi classification, if you are taking 100, 200 and 300, three categories are there. 100, 200, 300. If you are using soft voting and you are getting the answers of a 300, 300, 300, 200, 200, 200 and 100, 100. But 100 are coming 10 times. So he will go for the highest one. Total, he is going to one, highest one. The counts are important. Both are concept different. The counts are there. So soft voting combines the probability of each prediction in each model. Suppose one model is giving 100, second 100, third 100. So probability is nothing but which one is maximized. So both are based on the count, but hard voting the slightly different. That is an highest number of votes for the individual. For are putting for the, if suppose 4 votings are coming for the one, then highest count is an wins. Soft voting also same, but it makes the what each model and picking up the prediction of highest total probability. The both answers will come same. Why? Because always we are not getting an same answer like a 1 1 2 2 3 3 4 4. Definitely you will get a difference or different outputs. And your random state also changes. You, if you are setting up a random state is equals to 3 and odd numbers, then definitely you will get a different outputs, and always majority will win. Highest total probability, if suppose getting the highest total means, if suppose probability is nothing but you know that 1 1 1 is coming. If suppose 6 are there and 1 1 1 1 means 4 times 1 means he is making the sum of that 1 plus 1 plus 1 plus 1 and 0 plus 0. That is an highest probability means 1 1 1 1. The making total count and making the total two are two different things. No, are you getting, sir? The, at the end you will get a same answer. At the end, definitely. Soft voting and hard voting always. Hard voting means count, direct count. The 4 are there, the 4 ones are coming, the 4 counts are there. And making sum is nothing but 4 are coming, no, make a sum and 4 is greater than 0. 4 is greater than 0, that is in summing up and getting the output. And making checking the count is nothing but ones are coming 4, 4 greater than 0. Both at the end you will get an same answer. Got the point? Weighted average is kind of calculating the stat average, total numbers of n divided by the how much count. Same. Let me know the final vote. The way, see, I'm just giving you one example that final vote is equals to y period 1 plus y period 2 plus y period 3. What is the y period 1, y period 2, y period 3? Output. Do you know that output? Are you getting or not? Predictions, exactly. Predictions. Prediction 1, prediction 2, prediction 3 divided by 3. Whatever the final vote will come, no. Means, I will show you in the practical actually. Output from classifiers. Yes, sir. Output. Yeah, actually. Output from the classifiers. In the previously, we have defined here three algorithms, RM, L1 and KN. So everyone gives you some output, no? RM's prediction 1, L1's prediction 2, KN's prediction 3. Actually, voting classifiers and weighted average output somewhat correct. Same output. Because you are here, same concepts are voting. What is the work of voting classifier? Max voting classifier. Maximum voting checks and output. If suppose I'm passing here one observation and asking to the prediction one means random forest, logistic regression, and KNN. Asking to the three of them. And logistic, if suppose prediction one getting 1, prediction 2 getting 0, prediction 3 getting 1, and divided by 3. Who will win? 1 will win, no? Final vote, what is the final vote? 1, no? Because max average will get from 1 only. Why? Because the maximum average means 1 and 1 is a 2 counts are there. So what is the averaging concept? And here we are working on the probability, not on regression. And probably in the probability, always averaging will win. So maximum time I'm just thinking about better to use on the averaging because averaging gives you some slightly point means floating values. I will show you how the averaging works and all. Can you, is it correct? Are you getting these points? I will show you through practical as well. Don't worry. Wait, sir, I will show you one. Till here, everything is correct. Let me know. X train, Y train, X test. Is it correct? Yes or no? Okay, we'll go for some detailed over. Okay, you will enjoy this point. No problem. See, I have trained to the model random forest and n estimator I have taken. And max step, see, decision trees are nothing but step by step execution. Means trees are there, no? So how much depth of tree, how much that the branches, first stage, second stage, third stage, fifth, fourth, fifth, the max depth of 5, right? And entropy is nothing but cross entropy. There we have criterion is equals to entropy is nothing but how much ambiguity you have in the that depth, means that decision tree. Ambiguity means nothing but if suppose uncertainty is there, if suppose some problems are there. So criteria is equals to entropy if you are passing that, removing, checking the uncertainty between the data, the work of that criterion. So it doesn't matter that you it's not necessary that you can pass a criterion is equals to entropy and random state as well. Even you can pass through the n estimator is equals to 10 as well, not an issue, because random forest classifier is taking the by default some values, right? And so criterion is equals to entropy that we have taken, and RFC means that, wait, I'll show you one thing. I'll remove this point actually. Okay, I trained X-train and Y-trains data to the RFC. RFC means random forest classifier, and get some output of Y-train. So this is our random forest, normal random forest that uses the decision tree. Now I'm going to show you one thing. Come to the part, the first part that we have seen, random forest first part. In the random forest second part, I'm going to do, check out. I have implemented three classifiers. I have implemented three classifiers. So random forest classifier, second logistic regression, third k nearest neighbor. Is that correct? Means now we gotten three classifiers, that is three algorithms. And the way we gotten three algorithms, I have created three objects Rm, L1 and Kn that you have seen through, where do you have seen in the PPT that we have seen this Rm, L1 and Kn? Yes. And once I created, I have trained X-train, Y-train, X-train, Y-train to the Rm, L1 and Kn, means they have individually trained, not an issue. After training, they got an output at Y-pred, Y-pred 2, Y-pred 3. All the outputs are getting Y-pred 1, Y-pred 2. So everyone is giving some different outputs. See, I have asked one question, same one question to the everyone, and everyone has given different outputs. Check out the last observations. 3 0 0 0 0 0 0 1 0 0. You have asked the X-trace to the random forest classifiers. X-traced observations. How much count is there? It depends upon the wait, I will show you count of this one, because 200 questions you are asking to the each one, and each one is giving 200 questions answer. So these are the 200 total. X-trace you are passing on getting the 200 outputs. Yes or no? Yes or no? So after asking 200 questions, we are getting the three types of answers. Means everyone is giving his own. See what else? Everyone is giving his own answers. So we are checking the observation values of these last three ones. These three observations we are getting 0 0 0 0 0 0 and 1 0 0 0. Now if suppose I am passing three algorithms, three Y-preds to the max voting, at the end what will be the answer? Average answer of last threes. Average answer of last threes. It might be like 0 0 0. Is it correct? No, what I'm saying? That answer should be 000, no? When I'm applying max voting on these three, because three different classifiers are there. Is it correct? If suppose I'm applying max voting on these three classifiers, then definitely we will get a majority of voting on the basis of that, and last three one will come 000. And once I get, just check out the same concept I'm taking here. Voting classifier RM, L1 and KM. We train the X train, Y train to the max vote, and after getting max vote, I'm passing X test. Same questions that we have used, we have asked the previously three classifiers. The same question I'm asking to the voting classifiers, because voting classifier has RM, L1 and KM. And that's it. I'm going to execute this one. Check out. Now the point is to be some questions are there. Wait, we are getting the 010. Okay, we are getting 010, and wait, why he has given the 010? Wait, the voting classifiers gives you what answer? Check out 010. Second, I'm going to ask to the Ypred 3. He has given, I think, predict is, yeah, changed. Actually, what happens? I started executing from the previously. In the previously means while I'm explaining you, I have executed. I have remained same means execution that I have done previously, because directly I have opened no random forest part 2 and remain same. Now I have executed previous from this one here. That's why this is changed. Got the man, ma'am, this one. While I have done the execution previously, that I got this. See now, 010, and this is nothing but 0. Yeah, it's now, yeah, it is. Even I'm confusing about that. Why max voting giving us proper answer? This is quite interesting because the previously while we have started the ML basics, no, that time some of the people they asked me how to trust on model because this is giving you are executing one time. Then now you have a chances to check, means if you can use the one time, means one execution with the function with the classifiers, or you can go with the imbalancing problem statement, or you can go with the cross validation. And then there we have seen now the random forest, means ensemble technique, means you have a multiple options to check, means making the trustful model. And you are asking same question to the every, and then maximum voting will come, yes or no? Even I will use the averaging as well. See, averaging is the downside, that final vote in y period 1, y period 2, y period 3 divided by 3. See the final output. So averaging, see, actually what happens, I have used the np dot round. The round is nothing but averaging, is gives you the average values, no? So while I'm doing like this one, what will be the output of final vote? So you will get a kind of this one. Some will give you 1, some will give you 66.61. So if suppose if you are using rounding, then definitely you'll get an answer kind of this. See, yeah, it's correct actually. Averaging and max voting is are almost same, no? Because what is the use of averaging? So see, you will get a huge difference in the multi-classification, because here we are working on the probability. If suppose if you are taking the example of multi-classification, no, there will might be chances to get on some difference between the max voting and averaging. Is it correct? So in the probability, you will not get on that much huge difference. It looks correct actually, not an issue. And see, this is your average, means max voting. And now just see, here we are using bagging classifier. See what I'm saying? Word is my bagging classifier. Okay, bagging classifier. So what is a bagging? Bagging is nothing but bag. Its collection of subsets are using same algorithm. What I'm saying? Collection of subsets are using same algorithm. So now check out one thing. Are you there, everyone? Is it visible to you? Yeah. See, I have created a bagging classifiers object there, BG. BG is equals to bagging classifier. Base estimator is equals to L1. Now they got the point. Now let me know what is the L1. Exactly. Logistic regression. The way I said no, that you can use decision tree or different algorithms, different classifiers too. So you can base estimator is equals to L1 and n estimator is equals to 5. So how many estimators you are, how many subsets you are creating? 5. But who is the downside classifier? Logistic regression. And you are asking to the logistic regression, take my all 5 subsets and give me the output. At the end, he will give you the output on the basis of majority. And then I'm asking to the base estimator, n estimators are how much? 5. And 5 subsets are asking to the base estimator bg dot fit x train y train. Then you got a train of the base bagging classifier, and you will get an output bg dot predict x test and y predict. See, are you getting my point? It will take up 5 samples from the logistic. No, 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 not on 5 samples. Output purpose, he will take up 5 outputs. Means it's kind of 0, 1, 0, 0, 1, like that. You got the point here. The bagging classifier. It's kind of this one. No, wait, I will show you one diagram. So previously, I have shown you one example. Is it visible? The n estimators are nothing but, I said previously, this one. This is the n estimators. But classifiers, the way we have seen, no multiple. Only what you have done here, you are using logistic regression, logistic regression, logistic. And whatever the output will come, no, 0, 1, 0, 1, and you are asking to them. You are asking to them, and I'm getting the output like a 0, 1. Are you getting my point? You are asking 200 questions, then you will get an 200 outputs, bunch of outputs like that. At the end, I have seen only 3. Okay, that's why you are getting confused why this is 0, 1, 0 is coming. Actually, you are getting the 200 questions, then you are having 200 questions, you will get 200 only answers. So that's the point behind this max voting and this one. So ensemble is a very interesting point. And you guys are thinking about why a random forest classifier is using their n estimators only. Why not you have passed uh, there is a new classifiers there. Actually, what happens? Random forest classifier is using decision tree internally. Bagging classifiers can able to take different classifier, and max voting is different, averaging is. Are you getting my point? Yes or no? Actually, these are the things that very interesting points, and behind the scene is important. Means the way you guys are thinking. Means how, if suppose if I'm going for the random forest always looks for the decision tree. Going for the bagging always go for different classifiers. So you can pass their classifier object and get it output. If you're going for the max voting, you can define multiple classifiers and passing into the max vote and get the output, majority of output. Average same, average same. See, actually, what is the main? These are the files that I have shared with you. Once check out. Okay, let's go for the third one. Third one, I have done one example, so you can check. See here, I have used the stratify k-fold. What I'm using? Stratify k-fold. So can you tell me what is a stratify k-fold? cross validation technique. So what is the use of cross validation technique? That you can execute on the multiple unique values, and this is a really interesting point. If you this kind of structures that I shared with these are the things that companies are using, means for the checking as well. So they are checking, doing the R&Ds and all. See, please, one important point. Now I'm going to explain it. I have defined the stratify k-fold, and what is the behavior of stratify k-fold? It's he can maintain and balance the each loop of cross validation. What? He can maintain the balance. He can maintain as well as the balance the each loop of cross validation technique. What is the difference between stratify k-fold and k-fold? K-fold might we get a chances to imbalance into the cross validation technique. Stratify k-fold is an cross validation technique, and smooth oversampling and undersampling and oversampling, these are the imbalancing techniques, means handling the imbalancing problem. So I have assigned here, I will pass here only 5. So splits, he can create how much? 5 splits. He can create how much times? 5. And check out. So you know what what I have done. L1, he said that L1 is not executed. Why? L1 can also actually, guys, actually you have already gotten this answer where in previously. So I'll take that answer only. Okay, I'll take only answer. This one. I'll copy this code. Okay. So this is also voting classifier. This is. So voting classifier creates the 0, 1, 0. And now let's go for cross validation tech. Trend test data, KSF dot splitting XY, not an issue. Define the models, 3 models that you have created. See, created the models, train the models, and get the prediction YPRED, YPRED 2, YPRED 3. The way we got an output, no. Print YPRED 1, YPRED 2, YPRED 3. And here you apply the max voting concept in the looping structure as well, because every time X train and Y train's data is changed. Is it correct or not? This is the key point of your machine learning. If you got this point, no, you will enjoy so much this point in this time, because in the previous part of here, your X train and Y train isn't same. Is it correct? Your X train and Y train is same, but here your X train and Y trains are changes while executing the loop. Is it correct? Yeah. Yeah. The way we have executed X train, Y train, X train means every time your loop is executing, X train changes, Y train changes, X train changes, Y train changes, and at the end of the max vote dot predict, and X2 means what actually, how many max votings are we are getting, and how many, how much? 5 exactly. So that's why I got the YPRED underscore max, and then what? The execution started. See now. How many classifiers there? How many predictions we got because of these classifiers? The three. Every time three classifiers gives you three outputs and max voting is output one. So see, the first loop gives you three different types of answers and the max voting calculates these three. The first max vote gives you this output. Wait, I will show you one thing. I'll pass here only. Okay. First, second here. Okay. Third, this one. Fourth, and the last one that is this. See, I have previously actually copied the data, the first files. Okay, this is previous data, so I will just remove this one because these are the predictions previously we have executed. Okay, not an issue. So just let me know. This is a not an means easy or this is not a normal output. This is a max voting with cross validation output. Is it correct? No. And everyone, you can go for the majority of work as well. So you can while see, is it correct what I'm doing here? Are you getting point, everyone? So this is nothing but your general means general max voting means I have created general max voting, but these are the predictions. These are the steps are important. So if suppose general means combined max combined. Even max voting is also max vote I have created. That's why I have mentioned. Hope you got this one. These are the outputs come from the loop, no. So that outputs part, no, means general part, no. So that's why I have defined. What the point? Yes or no? I think the first one majority voting is zero. Yes. second majority voting one and third majority voting. Yeah, now this is now got the point. Yeah, this is correct. So is it possible to do a exercise with this one? Because today you got the whole scenario behind this ensemble technique and random forest. Is it correct? Actually, you have to take one example on this one. Not only I'm just thinking about the diabetes, you can go for the credit card fraud detection also. But if suppose if you are going with the credit card fraud detection, there we have a lot of data. So if suppose if you are not getting the steps, work on the small data set, clear the examples, clear the consequences, suppose clear the some problems if you are getting, then go for the deeper and deeper. Actually, one thing, even I will share uh, some questions as well. Questions means theoretical part that you have to learn. What is second? Can you upload these files? Actually, I have uploaded it, sir. Same, I never done any changes. Today I have executed only, re-executed only. These are the files already uploaded. What is ensemble? Even PPT also updated. Entropy means not considering uncertainty. No, he will check and suppose not only the uncertainty, there is an ambiguity is there, no, in the suppose data. That type of ambiguity he can check. Only part one is uploaded. I will check. I will check if suppose both are means. Actually, I have done all the one, but wait, I will check in front of you only because which day it is. Oh, not anything that we have. Part one. Okay, okay. Part one is there only. I will update part two as well. Wait. Okay. PPT and part two, please. Part two I did actually. Wait, I'll add the PPT two here. अजून वेळ 15 मिनिट नाही जा चालतं काय ऐकता का ओनली पाणी I just updated on the portal, no. So I'm just thinking about you got through the portal or not, or might be taking your time for updating purpose. But what unsupervised actually in the tomorrow actually we are going to cover up the other algorithms related with the supervised. Maybe chances to start the Sunday or next week we'll cover up the unsupervised learning. Means there we have the clustering algorithm, no, that we have. So I think within this week or next week we'll cover up the machine learning points and we'll go for the other world as yes. I think you got the today's session. The updated maybe, ma'am, it will take a little bit time, but I have updated this. No one. Yeah, yeah, yes. Okay, no problem. If there is an issue, we'll cover up then tomorrow as well. But go for and work it on it. Okay. Thank you so much for this today's session. Enjoy. Take care. Thank you.